Hello, this is Ms. DB, and we are going to continue our lesson on 12.4 geometric sequences and series. We did part 1 in a previous video, and we're going to start with a pretty simple concept about geometric means, which is a type of geometric sequence, and then we're going to find the sums of geometric series. So we're going to start with geometric means, and like I said, this is pretty simple. You did this in geometry in finding parts of similar triangles. You probably did this. So a geometric mean is just when you have two terms of a sequence with one term in between them. The geometric mean is given by the following expression, and you multiply them together and then you take the square root of it. So if you have these two terms of a sequence and there's one term in between it, you can multiply these together and then take the square root of that, and that gives you what's called the geometric mean. And mean is like average. This is kind of an average, but it's different because it's a geometric mean. So if you multiply 4/9 times 25 over 36, I'm just going to simplify that a little bit. 4 goes into 4 one time, and 4 goes into 36 9 times. So we end up with 25 over 81. When we take the square root of that, those are both perfect squares, and we get 5/9. Here's another example, the geometric mean of 16 and 25. If you multiply that together, you'll get 400, and if you take the square root of 400, you get 20. Now, you don't always get perfect squares when you do this. Sometimes when you take the square root, you'll get a decimal, or you can simplify your square root using the techniques that you've learned previously. So I didn't put any problems from geometric means from our worksheet on here because there's a few problems on the worksheet that have to do with that, but they're quite basic. All right, so next thing we're going to do is get into finding the sum of the specific terms of a geometric sequence, and that's called a series then, when you want to add them together. And remember the sigma or summation notation that we use, we'll use that a little bit today as well. So you can figure out the formula for this as shown below. We won't actually have to do this, but this shows how they came up with the formula. They wrote out the terms and then they subtracted and came up with this right here. This is what we're going to be using, is that the sum of however many terms you want to find is going to be equal to the first term, a sub 1, times 1 minus the ratio to the nth power over 1 minus r, the ratio. So you'll see that we need to find the ratio, or be given that. We'll need the first term, and then we'll need to know what term we're trying to add up to, the n. So here's another formula to learn and put in your notes and write on your wall. And we are going to go ahead and start practicing. So if we're going to add this series together, we can't add the whole series together because you can see that this is going to get bigger and bigger and bigger and bigger. So we're just going to find a partial sum, and in this one we're going to find the sum of the 1 through 8 terms. So here's the first term, the second term, the third term, the fourth term, and so on all the way up to 8. Now you could write them out and then you could just add them up on your calculator. That's a good way to double check your answer, but sometimes you'll be looking for the 30th term or the 20th term, and then we don't want to have to mess with doing that. And sometimes your numbers will get really big too, and or decimals or fractions, and you don't want to have to add them all up. All right, so our first step is to find r. And we find r just like if this had been a sequence, and we take the second term divided by the first term, and we get 2. And we just double check that with maybe this term divided by this term, 8 divided by 4, that's also 2. Okay, so our common ratio is 2, we know r. We also know that the first term, a sub 1, is given to us as 1. We are also given that we are looking for the sum up to n equals 8. So we use n for 8 for n. So you write down the formula. Always start by writing down the formula, and then we just replace. We substitute in this, a sub 1, r, n is going to be 8, there's r again. So all of those circle parts are going to be replaced with what values were given in this problem. So S sub 8 is equal to 1, that's kind of nice, times in the numerator, we have 1 minus 2 to the 8th, and we'll have to do the 2 to the 8th part. And then in the denominator, we get 1 minus 2. So now we simplify. The 1 still stays as the 1. Then on the numerator, we have 1 minus 2 to the 8th is 256. And then in the denominator, we have negative 1. So this all gets simplified to negative 255 over negative 1 times 1. And a negative divided by negative is a positive. And of course, 1 times any number is itself. So we just end up with 255. So the sum of the first 8 terms. Okay, now for another example, we are going to work with a fraction in this one. So we're going to be finding the sum of a geometric series when we have the sigma notation. So we're going from k equals 1 to 6, and our common ratio is 1/2. That's what it is in parentheses here. And we are to the k minus 1. So our first step is to find the first term. Since we know that r is equal to 1/2 in this case, then we can go ahead and start by finding the first term. To find the first term, you just take k equals 1 and you plug it into our expression. So we would have 1/2 to the 1 minus 1, which is 0, and anything to the 0 power is 1. So our first term is just going to be 1. Next, we are going to plug in what we know into the formula. So we know a sub 1 is 1. We know r is equal to 1/2. And we're looking for the 6th term. This will tell you what number to use for n. So we plug in s sub 6 is equal to 1 times 1 minus 1/2 to the 6th all over 1 minus 1/2. Now don't let the fractions scare you here. It's only a fraction of a half, so it's not going to be bad to simplify this at all. So first of all, the 1 times, we don't need to multiply all of this by 1. So you can start by simplifying this to just 1 minus 1/2. Let's do 1/2 to the 6th. So 1 to the 6th power, of course, is just 1, and 2 to the 6th is 64. So that simplifies to 1 minus 1/64, and 1 minus 1/2 is just 1/2. What is 1 minus 1/64? Let's do that over here. That's the same as 64 over 64 minus 1/64 is 63/64. So this is going to simplify to 63/64 divided by 1/2. Now you probably have a fraction calculator that you can use to check this. You can also take 63/64 times the reciprocal of 1/2, which would be 2 over 1, and we'll get 63 over 2 goes into 64 32 times, so 63 over 32. So our sum, after all of our calculations here, is going to be 63 32nds. Is that how you would say that? Or they wrote that as a decimal. Let's just double check that 63 over 32 is indeed about 1.968, exactly 1.96875. I would have left it as a fraction though. All right, so, and do look here, they did not round that very much. So write out all of the decimals that you get, all the decimal digits you get, or else at least put the first 3 or 4 decimal values after the decimal point. Okay. All right, this is one from your worksheet. We are going to find the sum from k equals 1 to 5 of -3 to the k minus 1. So our first step is to find the first term. So we are going to take and plug in 1 for k. So we'd have -3 to the 1 minus 1. 1 minus 1 is 0. So we have -3 to the 0, and anything to the 0 power is 1. So a sub 1 is equal to 1. Our ratio is -3. So we're ready to use the formula. Oh, and we'll use n equals 6. So in the formula, we are going to put a sub 1. Well, first of all, we'll go s of 6. We want the sum of the first 6 terms. A sub 1 is 1. The numerator will be 1 minus, the ratio is -3 to the 6th power. And the denominator is 1 minus -3. And then we just keep simplifying carefully. The 1 times all of this is not going to change my answer, so I'm just going to work on the fraction on the inside, and I'll have 1 minus. Now I need to take -3 to the 6th power. So if you're using a calculator, put the -3 in parentheses before you take it to the 6th power, or you won't get the right answer. So it's positive 729, and then the denominator is 1 plus 3, which is 4. So we simplify and we get negative 728 divided by 4, and that is equal to 182 negative. So that means that S of 6, the sum of the first 6 terms, would be negative 182. One more example. This is an application problem. It says that a 6-year lease states that the annual rent for an office space is $84,000 the first year and will increase by 8% each additional year of the lease. If you have something increasing by a percent, then you would add 1 plus that percent. If you have it decreasing, then you would subtract. So since the rent is going to increase, we will take 0.08 plus 1. So we have 1 year. 1 plus 0.08 is 1.08. This is our R. Our A sub 1 is going to be the 84,000. And they want this after 6 years. So they want to know what is the sum that they would have spent on rent after 6 years. This is going to be a scary number. It's going to be a very big number. So it must be a very big building. So S sub 6 is equal to, this is A sub 1, which is not 1 like it was in the previous examples. And then we have to take 1 minus 1.08 R to the 6th, because it's to the n, all over 1 minus R. And they magically did the math and got this giant number, 616,218. Let's go back and see how they got that giant number. So this time we can't just not pay attention to that. We're going to need that. So I put that out front, and now I'm going to take 1 minus, okay, I need 1.08 to the 6th power. So I use my calculator and I do 1.08 to the 6th power, and I get, I'm going to write out all of these digits even though there's a lot of them. All over 1 minus 1.08. Now I'm going to, well, I'm going to store this in my calculator and go 1 minus that, which is going to be a negative number, and it'll be negative 0.5868743. I'm writing all these down, but I'm actually storing them in my calculator as I go. Now I'm also, can't forget my 84,000 in front. I'm also going to take 1 minus that. 1 minus 1.08, the denominator, is just negative 0.08, of course. So I need to take my top number divided by my bottom number. So let me get my values back where I had stored them. 0.58687, and divide that by negative 0.08. Now this will be a positive number because I have a negative divided by a negative. And it's about, well, I'm going to have to start rounding at some point here, but I got 7.3359. I'm going to round that to 6. And that I multiply by the 84,000. And that gives me almost exactly what they have. I got 0.0381. They rounded that to 0.04 because they're rounding to the nearest cent. So that's how you would get that value. And it's not complicated math, but you do have to be careful that you're computing things correctly and making use of your calculator the way it was designed to be used. And that's it for today. Thank you very much, and let me know if you have any questions. Thank you.